Imagine driving down a winding mountain road, the engine humming in sync with your movements. Every gear shift sending a jolt of power to the wheels. Whether you're behind the wheel of a rugged manual or a smooth automatic, one component is silently doing all the hard work: your car's transmission. But how exactly does it work? And did you know there are multiple types of automatic transmissions, each with their own secrets under the hood? Before we dive into the gear grinding, torque shifting mechanics of how manual and automatic transmissions operate, don't forget to subscribe for more in-depth automotive breakdowns, tech dives, and real-world explanations that demystify the machines we rely on every day. What is a transmission and why is it so important? At the heart of every vehicle lies its transmission, a system that manages the power generated by the engine and delivers it to the wheels. Think of it like a translator between your engine and your tires. The engine operates best within a narrow band of speeds, called RPMs, and it's the transmission's job to make sure the wheels spin at the right rate, no matter how fast or slow you're going. Without a transmission, your car will be either sluggish at low speeds or dangerously over-revved at high speeds. In simple terms, the transmission changes the gear ratio between the engine and the wheels, allowing for smooth acceleration, fuel efficiency, and control. Now let's break down how both manual and automatic transmissions work, and the different types of automatics you probably didn't even know existed. Manual transmissions, the classic driver's machine. If you've ever driven a manual car or watched a fast-paced racing scene in a movie, you know the feeling. One hand on the wheel, the other on the gear stick, and your foot dancing between clutch and accelerator. But what's actually going on when you shift gears? A manual transmission consists of several key components: the clutch, flywheel, gear selector, and a set of gears on two shafts, the input and output shafts. Here's how they work together. When you press the clutch pedal, you disengage the clutch, a mechanical linkage that separates the engine from the transmission. This prevents power from flowing to the wheels, allowing you to change gears without grinding the cogs together. Then, using the gear stick, you select a gear. Inside the transmission, you're physically moving gears into alignment. These gears vary in size and tooth count, which changes the gear ratio, essentially deciding how much torque or rotational force is delivered to the wheels versus how much speed. Lower gears, like first or second, provide more torque and are used for acceleration and hill climbs. Higher gears, like fifth or sixth, provide less torque but greater efficiency for cruising speeds. Driving a manual car well means mastering the dance of clutch, shift, and throttle, earning you a level of mechanical connection and control that automatic drivers never experience. Automatic transmissions, magic in motion. To most drivers, automatics are seamless and effortless. You just slide the gear selector to D and let the car handle the rest. But under the surface, an automatic transmission is performing an intricate ballet of fluid dynamics, sensors, and computer logic. Unlike manuals, automatics do not require a clutch pedal or manual gear shifting. Instead, they use a torque converter and planetary gear sets to manage power flow. The torque converter replaces the clutch and allows the engine to spin independently of the transmission. It uses transmission fluid and a turbine system to transfer rotational energy, a kind of fluid-based handshake between the engine and gearbox. But here's where it gets even more fascinating. Not all automatic transmissions are created equal. Let's break down the different types of automatic transmissions you'll find in modern vehicles. 1. Traditional automatic, hydraulic, or torque converter automatics. This is the classic automatic transmission found in most older cars and many trucks. It uses hydraulic pressure, sensors, and a torque converter to shift through a fixed number of gears, usually 4 to 10 speeds. Pros: smooth shifting, great for towing or high torque needs, reliable and well understood by mechanics. Cons: less efficient than other modern automatics, heavier and more complex. 2. Continuously variable transmission, CVT. CVTs don't use fixed gears at all. Instead, they rely on a pair of pulleys connected by a steel belt or chain that can change diameter, continuously adjusting the gear ratio for optimal engine performance. Think of it like a bike with infinite gears. Pros: Super smooth acceleration. Excellent fuel efficiency. Fewer mechanical parts. Cons. Rubber band feel. Some drivers dislike the lack of gear shifts. Not ideal for high performance or towing. More complex to repair. 3. Dual clutch transmission, DCT. A dual clutch transmission blends the best of manuals and automatics. It has 2 clutches, one for odd-numbered gears and one for even-numbered gears. While you're driving in one gear, the next one is already pre-selected. When it's time to shift, the transmission instantly swaps clutches for a lightning-fast gear change. Pros: ultra-fast shifting, great for performance cars. More fuel efficient than traditional automatics. No torque converter. Cons: jerky at low speeds. Expensive repairs. Can wear out quicker in stop-and-go traffic. 4. Automated manual transmission, AMT or semi-automatic. An AMT is essentially a manual transmission with computer-controlled clutch and shifting mechanisms. It uses actuators to do the shifting for you based on driving conditions. Pros: cheaper to produce. Good fuel economy. Popular in budget cars in markets like India and Brazil. Cons: not as smooth as other automatics. Noticeable delay in gear changes. The future of transmissions. Are gears going away? As we move into the age of electric vehicles, EVs, the idea of transmissions is changing altogether. EVs typically have a single-speed transmission because electric motors deliver maximum torque instantly. There's no need to shift gears. Acceleration is smooth and constant. However, some manufacturers are experimenting with multi-speed EV transmissions to improve performance and efficiency at higher speeds. Porsche's Taycan, for instance, features a 2-speed gearbox to balance acceleration and top-end speed. In the coming years, as electric technology advances, we may see the traditional concept of gears disappear altogether from mainstream vehicles. Conclusion: more than just a box of gears. Whether you're easing through traffic in a modern automatic or carving up back roads with a manual, your transmission is doing incredible mechanical work to keep your ride smooth and responsive. It's one of the most complex and fascinating systems in your car, an unseen hero of every drive. Understanding how different transmissions work not only makes you a smarter driver, but also helps you make better decisions when buying, maintaining, or upgrading your vehicle. And remember, subscribe for more deep dives into the hidden tech that powers our world. From engines to electric motors, gears to gyroscopes, we've got stories that shift your understanding of the machines that move us. Thanks for watching, and keep driving curious.